Welcome everybody to class. Quiz should be open. Welcome to class, everyone, as you're coming in. The quiz is live. And of course, the password is up. Welcome to class. We got 4 more minutes, about 3.5 more minutes, and then the quiz is done actually about 3 minutes. Okay, just finishing it up here. Okay, welcome to class again. It's time to start. So, as you can see, computer science quote for the day is, "I've always wished for my computer to be as easy to use as my telephone. My wish came true because I can no longer figure out how to use my telephone." This is Bjarne Stroustrup, who actually created the language that we're going to start learning now, C++. So I thought that was appropriate. And lab 6, of course, is due Thursday. A lot of people have been coming in. I'll mention something. I did send out an email about that. I realized there was some flaws in the original code, and I can't, once you've started it, you don't see any changes I made. So I gave you an update that you can copy code out of that is, I cleaned up basically some errors I made in the starts code that would possibly be a problem for some of you. C++ REPLs start to be due on Thursday. Those are pretty simple ones. You know, based on what we learned today, the REPLs work just like the Python REPLs. And so you'll want to get your hands in there and start looking at that and doing it. Well, RELPs. The C++ book, some people say that they've had some problems getting into the textbook. So let me show you how you do that. Okay, so if you go to the textbook, to the page, and you go down and look into text, here we see Kenyon SCMP118 S21 SCON CP. It has to be just like this. all the right capitalization and everything. So copy that and go to Runestone and log in. And when you log in, you usually, now you see a lot more because I have a lot of courses, but you usually see your course, and down at the bottom you see enroll in a course. You simply click on that. This stuff should already be filled in. Then you go here and you paste that in, apply changes, and then the next time you go here, you'll see the new course. That's it, okay? So if that doesn't work, let me know, but I think most of you have reported that worked fine for you. Two-dimensional arrays, I'm trying to remember, for some reason my brain isn't remembering. I put out an example on two-dimensional arrays that are useful for some of the assignments. And so I wanted to point that out. Did I go over this code or not last time? Somebody tell me.
You did.
I did, okay. So does anybody, I put some additional comments in there. Did anybody have any additional questions on this? Okay, so this does a lot of the work, really gets you going on a lot of the problems. So I just wanted to mention that.
I just have a question. Where is this?
This is here. If you go to the web page, and if you go to the last class, which was apparently April 15th, notice two-dimensional array code. You click on that, and that takes you there. And so that's very useful code. Okay. So today, of course, we're not going to do a code, so I'm going to talk to you about C++. And yes.
I have one more
Okay.
class-related question.
Yes.
Is Lab 8 our final exam?
Yeah, we're not going to have an actual in-class exam. That's right.
Okay, all right, that's all I
So usually we do, but for COVID times, I decided to take that pressure off of everybody. And so, thanks for asking. So before we talk about C++, you know, C++ is a very important language. It's one of the most commonly used languages. If you go and interview for Google or Apple or any place like that, they're going to want you to know C++. I mean, it's a foundational language. It's a language that you know, most critical infrastructure code is written in. I write code in C a lot, which is closely related to C++. I've written, you know, I've spent tens of thousands of hours writing C code. It's a language that I am intimately familiar with. Unlike Python. Python is a language I only learned like 3 years ago so that I could start teaching it. Whereas C++ is something I know very, very well and I enjoy and I really like it. So that's just sort of giving you my history with C++. C++ is a very powerful language with lots of features because it is a high-level language that offers low-level features. Now this is important because it allows you, it sort of spans the breadth of being able to write simple programs, but you can also build entire operating systems out of it. You know, and many major applications are written in C++. You don't have to know all of C++ to be able to use it effectively. It's influenced so many other languages, such as Microsoft's C# language, Java, which is a very popular language, and other versions of C, newer versions of C. So by learning C++, there's a whole lot of other languages that you're going to find are going to be very, very similar. JavaScript's another one, which is a very popular language used for programming web pages. C++ is an industrial strength programming language and often used for large systems by large groups of people. You know, as I mentioned, you know, the code I work on a lot as part of the FreeBSD project is 32 million lines of C code. And so C++ is particularly good at talking directly to the hardware. This is important if you want to build an operating system or you're doing some sort of small embedded devices that we see all around us now that control things and talk to things. For example, I'm working on a project to create a new type of wireless access point, and that's all in C and C++. Why C++, not Java? C++ was the first widely used object-oriented language, OOP, supporting the four primary features of object-oriented. Abstraction, which we've talked about. Inheritance, we haven't talked about that as much, but it supports it. Something called polymorphism and encapsulation. We'll talk a little bit about these later. Because C++ is fast, is currently the language of choice for computer graphics and high performance modeling and virtual reality and 2D and 3D engine games, right? Most gaming software is written in C++. And it's still one of the top listed job advertisements. Let's look at the Toynbee index for April 21. Game over for Objective-C, which was a language that Apple used to use. So we can see the most popular language right now, number one is C, is good old-fashioned C, which again is my most used language. Next is Java, Python, then C++, C#, and then on down. JavaScript is pretty popular. So that kind of gives you an idea the popularity of some of these languages. So let's look at a C program. Now remember, back at the beginning when we were all mystified by programming, we wrote a program that basically just said hello, right? In fact, that's what we do oftentimes in languages. We make the first program be our hello world program, which just prints out hello world. Now we can remember in Python, writing a program that prints the statement hello world is very simple. It just requires print, parentheses, and in quote, hello world. It takes a little more in C++, it turns out. It takes all of this, and some of this looks like gibberish. But most of this is just common to every program you're going to write, so it'll just sort of disappear into the noise. But we can see the critical line here, C out, and then we have these two less thans, and then we have hello world, and then we have a /n, which we're familiar with, which means go to a new line. This actually prints it out. Everything else is stuff that's required to make a C++ program work. Now, if I go into REPL, let me see, I think I went in there, let's see. Yeah, here we go. You can actually click on that link and we go into C++ instead. And here we see that exact code. Don't look at that. Ignore the man behind the curtain. And we see, we run it, and hello world. Wow. Okay, so now this is a little different because we have this STD here. We don't have to have that. It turns out that here we did something a little different so that we didn't have to do that. In fact, I should probably make this match our program, and I'm going to do that. So, because I don't want to confuse you, using name space STD. And then I can get rid of this, and it makes it a little nicer looking. So anyway, it runs. Now, let's bring this thing back to life, and we're going to kind of talk about what we're looking at here and sort of demystify this. Now, this include IO stream, include is like an import in Python, and it turns out in C++, you have to bring something in if you want to do input and output. And so this pulls in all the input-output stuff. You're virtually always going to have this unless you have some program that doesn't need to do input and output from a terminal. The brackets mean this is a library that's a part of the system, because if you define your own library, you put quotes around it, but the greater than less than means this is a built-in library. Every C program always starts out with the function main. You always have to have a function called main. You have to. There's no way out of it. And so this says main, and notice you can kind of think of this like a def, right? Def main, only in this language we don't use the word def. So we're defining a function, and it turns out it's an integer function, which we'll talk about what that means later, but it's a function main. Now notice that we have these braces, the curly brackets, right? And they're wrapped around that's what we do. We don't use tabs and spaces the same way in C++ as we do in Python. In fact, you don't have to do any spacing at all in Python. In fact, you can do everything, I mean in C++, you can do everything on the same line, but don't do that. We want you to indent things, and we want you to indent them similar to the way Python makes you do it, but you don't have to do it, because Python uses these brackets to determine where the beginning and end of the code are. So basically we have main. This says this is the beginning of main's code. Here's main's code. This is the end of main's code. And at the end we have a return 0. It turns out that by convention, main returns a 0 if everything went okay, and it returns something other than a 0 if there's a problem. Now, it turns out that all C++ lines that are actual commands end in a semicolon. So this is a line that's a command. This is a line that's a command. Now this isn't. This is the header, the beginning of a function and the end of a function. So we don't have semicolons there. We do have a semicolon here. We actually never have semicolons after the include. Most of the time you're going to put in semicolons. Again, formatting in C++ is free form. Spacing in new lines mean nothing, but you're encouraged to do them. But we indent anyway to make the code look nice, right? In fact, you are required to do that, or you get a bad grade. Any questions on this? Okay, now Python uses an interpreter. We talked about this a little before. Probably didn't think a whole lot about it, but we're going to talk about it again because this is an important difference between Python and C++. Again, to use an analogy, imagine if you want to do something in German, but you don't speak German. What are your options? Well, one option is you can get an interpreter, right? You can say, like, for example, if you want to talk to somebody else who speaks German and you don't, you might find somebody who speaks both German and English, and they act as an interpreter. Somebody says something, the interpreter then repeats it to you in your language. So that other person says something, they repeat it to you in your language. You say something back, and then they turn it back into German, right? And that's called interpreting, and you do it sort of a sentence at a time in real time as it's being done. That's the way Python works. Python reads a line of code, figures out what it's supposed to do, and then does it, okay? So here we see how interpreter works. We have our program. The interpreter looks through the program and produces whatever output it's supposed to put out. Some uses compilation. You can think of compilation like translation, right? So, you know, we take some author like, you know, Fyodor Dostoevsky, the great Russian novelist, and we take crime and punishment, that was written in Russian, and we can't read Russian, at least I can't. So what do? We go and buy a translation. Somebody sat down, they did all the hard work once, and now thousands of people or millions of people can read the book once it's been translated. Now that's what C++ does. C++ takes your code and it compiles it into the language of the computer so that then every time you run it, it doesn't have to do any figuring it out. It just runs it in the native language of the computer. This is one of the reasons why C++ is faster. It takes a little time to compile it, but once you compile it, the program can run and run and run and run, and it always runs much, much faster than Python. Another advantage, by the way, of compilation is you discover all the syntax errors when you compile it before you actually run it. Whereas Python, you can have a program that has an error in it, but you don't see it until it gets to that line. And so if you make a program and you deliver it to somebody to use it, but you missed testing a particular line, they could get a syntax error in a program that they thought was okay. Okay, now all comments are important in all languages because we need to tell the user, programming is a human activity. It's an activity where people need to be able to read the code. Now it turns out there's two ways to do commas. We don't do pound signs. In fact, pound signs are what we use for the include, for example. What we use for comments are one of two things. We can start a multi-line comment with a /* and then everything until this */ is a comment. Another thing we can do is we can just use 2 slashes. Now, actually, I want to change this slide because I actually don't like, I want to show you, you can actually put a comment anywhere. So we could actually take this comment and put it at the end of this line, and that's just fine, just like you can, right? In fact, you can also do this. Okay. And that's going to be about, this is a valid comment. This is a valid comment. This is a valid comment. So that's /*, // and //. Now, the data types, the simple data types in C++ are much like the simple data types in Python, which, by the way, it's not a total surprise. I'm going to let you in on a little secret. Guess what? Python is written in C++. What does that tell you about C++ and Python, right? Nobody would ever write C++ in Python, but the Python interpreter is written in C++. That's because C++ is a much better system language. It's a fast language. It's a language that people build things on top of. So what are the data types? Well, bool is what we use for true or false. Boolean is what that's short for. Now, char is what we use for a single character. Now notice we use single quotes here. This is important because a single character is always in single quotes. Double character, it turns out, double quote, it turns out, is a string, which is different than a character. But that's not a simple data type, so we're not talking about it here. A float. Now, the difference between a float and a double is a little bit subtle, but not too subtle. They're both floating point numbers, in other words, numbers with a decimal point, much like a float in Python. However, in C++, you can choose the precision of your numbers. If a number doesn't have to be that precise, you can use a float. If you want it to be much more precise and have more digits of accuracy, you use a double. So basically the typical difference in most computers is a float is just 32 bits and a double is 64 bits. So it has twice as many binary digits for storing information. So it can be much accurate, and it can also span a broader range. And then an integer, an int. Whoops. Now, one important thing about C++ is you must declare everything before you lose it. No exceptions. You can't just start using a variable. So here we have some code, int xy, float speed, double av, bool done fast, character C. So here we're defining variables. Now here we're using them. X is equal to 17. That makes sense because it's an integer. Y is equal to 0. Speed is equal to 34.4. Again, that makes sense because speed is a float. Average is equal to 2.66. Again, makes sense since that's a double. Done is equal to true. Fast is equal to false. Now, notice that true and false in C++ are lowercase t and f, unlike the uppercase t and f in Python. That's a little different. And then we're having C is equal to quote R because C is a character. It can hold exactly one character and no more. So now it turns out that you can define variables with give a variable a value when you define them. So here we've taken this code and shortcutted it by basically doing the assignment at the same time we created it. Now in Python, we didn't have to do the creation process. In fact, we didn't even have to tell the type of a variable. All we had to do was just say some variable is equal to some value. Now this brings us to an important point. C++ is strongly typed. Variables do not change type, right? In Python, you can say x is equal to 1. Later on, you can say x is equal to quote Kenyon. Python doesn't care. Any variable can be any type, anytime. Python does not care. Not so in C++. And this, by the way, has a lot to do with the fact that C++ is compiled. Because it's compiled, you have to build it correctly ahead of time. And so you need to know the types that things are going to be. And once you set something to a certain type, it can never change.
Professor,
Yes.
is that true within functions as well, or can they change between functions?
You mean a local variable? Is that what you mean?
Yeah.
Local variables are independent variables. So you could have a local variable named x in one function that's an integer, and in another function, it could be a double.
Okay, thank you.
Because they're completely different variables. That's a great question. But a particular instance of a variable within its scope can never change its type. Totally can in Python. Okay, so that's kind of the basics variables. Now, there's a lot of similarities, but it's not identical. Here's another thing. Conditionals, right? In Python, we say f some condition, and then we have a list of indented statements. We've seen that a million times. In C++, we say f, and we have a condition that looks very much like, but although not identical, we'll talk about conditions, but it's a similar condition to a condition in Python, that if it's true, the code is executed. If it's false, it's not. Now notice though, the condition must be in parentheses. In Python, it can be in parentheses, but it doesn't have to be. Here it has to be in parentheses. And then we have the statements inside of a matching pair of braces. So here's some sample code here. Let's see here. Here's some code And let's look at it. It's got some comments. Then it says include IO stream using nameplate standard. Just put that in there. We'll talk about what it means later. And then we have main. Here we're defining a variable x to be an integer, and we're putting 50 into it. Here we're declaring y to be an integer, and we're putting 100 into it. And then I say if x is less than y, print hello world. Well, let's try it out. Is x less than y? Yeah, it prints hello world. Let's change this to 500. X less than y? Nope, doesn't print hello world. Okay, again, condition is inside of parentheses, code is inside of braces. Here's my present, there it is. Okay. All right, now we can have also if else, right? In Python, remember we do if condition, some statements indented, else, colon, and then some more statements. In C++, we say if condition, and then we have our bracket, then we have our statements, which must have semicolons after each one. Then we do our end bracket else and our next set of statements for the else condition. And notice we have 2 brackets here for the else, 2 brackets here for the if. Now I can actually make this look a little nicer, and this works. I can put the else on a different line or in the same line or whatever I think looks nice, because it doesn't care. C++ doesn't care about formatting. Okay, let's look at some more code here. So here we have x is equal to 50, y is equal to 100. If x is less than y, see out x is the least, else y is the least, because we're trying to find out the smallest value. There it is. 50 is the least. Let's change 50 to 500. And now 100 is least, right? So we've got some variables. We've got our if condition. None of this should be a surprise. So far, so good.
Need to include the return 0 every time.
The return 0 only goes at the end of main. You don't have to do a return 0. Yeah, let's look at this. So the return, well, yeah, turns out you don't have to return the term. It turns out if you don't return something, it just returns a 0, which is the right thing to return anyway. So some compilers are stricter about this than others. Some compilers will complain if you don't return something, others won't. This one apparently doesn't, but we could. In fact, let's try this. Return 0, semicolon. I got to put a semicolon at the end. We run it, and it's fine. Let's change it to 1. See what happens. Exit status 1. That's an unusual thing to return, so it kind of warns us about that. Exit status 99, but 0, get nothing, because that's the normal exit status.
Okay, thank you.
Okay, good questions. All right, now it turns out that, remember we have the LF in Python? We don't have the LF, right? We have f greater is less than 60, print s, LF, greater is less than 70, print f, LF, LF, else, print. We don't have an LF, but we can do the same thing with an else and an f. And this is what it looks like. Same exact code. Integer main, grade is equal to 85. If grade is less than 60, we'll talk about this, but this is basically doing the equivalent of us printing cout f. Else, If grade is less than 70, print out a D. Else F, if it's less than 6, right? So these are just like the else F, only we actually spell out the word else F. And it's going to happen from the top to the bottom. And the else here is what it does, just like in Python, if it doesn't find a match. And I think we have some code here for that. So we set grade equal to 76 and we run it. And we get a C because C is between 70 and 80. Okay. Where are we at here? Okay. So now, what about loops? You can see, so far, you might have been kind of worried that, oh, I don't know what my watch is doing. You might have wondered, well, how can we learn another language? Well, there's a lot of similarities here. And this is true in general. Once you want to learn how to program in one language, moving to another language is not as hard as learning a new language, right? It's not like going from English to Russian, right? And then, oh, now I know Russian. Now it should be easy to learn Chinese. Doesn't work that way, right? But here, once you know most computer languages, the other languages are pretty similar. So here's a Python loop. Remember, a Python loop is a condition, colon, and a series of statements. Not surprisingly, in C, we can do a while, condition in parentheses, and then we have our begin and end brackets, and inside of it, we have as many statements as we want, and it's going to keep executing those statements over and over again until the condition is false. So as long as it's true, it's going to keep doing it. Here's some examples. Here we have a Python program. It says counter is equal to 1 while counter is less than or equal to 5. Print hello, counter plus equals 1. What's that going to print?
Hello 6 times.
Yeah. Well, it's going to print it 5 times because we're starting at 1. So it'll do it for 1, 2, 3, 4, 5. Now over here, we got the same thing, an integer counter 1, and then we say while parentheses counter less than equal to 5 are brackets, and inside the brackets we see out hello, and then we increment our counter. Now it turns out there's a for loop. Now here things get a little bit different. In fact, quite a bit different. So let's look at this for a second. So in Python, if we want to make an x in the range of 0 to n minus 1, we can do it this way. So whatever n is, if n is 4, it's going to do it for x equals 0, 1, 2, 3, and then it's going to be done, right? That's how it works. Now there is no range in C++. Instead, it says 4, and then in parentheses, we have 3 pieces. The first piece is what gets done before the loop starts to set things up. So here, the for, and before, what we do when we come into this code, the first thing we do is we create a new local variable just for the loop called x. If there was an x outside the loop, that one disappears because we've printed, at least for while we're in this loop, because we've created a new variable x. Second thing is how to know when you're done. This is how to set it up. How do you know when you're done with this loop? Well, what you do is you have this second thing separated by a semicolon, colon, and this is the condition. It's going to test every time through the loop. As long as this is true, the loop will keep executing. So it's going to set x equal to 0. If x is less than n, it's going to do these steps. Now, what's it going to do at the end of the loop? Well, at the end of the loop, that's what this third thing says. It says what to do at the end of the loop. Well, here's where we see where C++ got its name, because there's an operator in C++ called plus, and the plus operator is exactly the same as saying x is equal to x plus 1. It's called an increment. We're just incrementing to the next value. That's why C++, it comes after C, because it's C plus plus, the next C. So this says start at x, as long as x is less than n, do this, and at the end of each one of these things, add 1 to x. That makes sense? So here's an example, right? So here we have for x in range 5, print hello. That looks nice, very common. We've seen that before. Here we have for int I equals 0, as long as I is less than 10, this is actually going to print 10n. Print hello, and then it says I plus plus because we want to go to the next I. So it's a little more complicated, but it's also frankly more flexible. Now here's another for loop inside of an entire program. Here's our program, here's our including of the IO stuff. Now, in the function here we have our main. Here's the beginning. Where's the end of main? Is it this bracket or is it this bracket? First one or second one? Anybody?
The first one?
So you say this matches with this?
Second one.
Now
No.
notice though, yeah, there's another one here, and brackets like parentheses have to match, right? So this is going to have to go to this one, and this one go to this one, because otherwise, whoops, it doesn't have any place to match, right? So this is outside, and these two are on the inside. See how that works? So what do we do in a loop? Well, in a for loop, we consider the first part in that for statement to be the initialization code. In other words, it says set things up, get things started. Do this once, set I equal to 0 once to initialize the counter. Then the next thing is check loop complete, done by before loop body. Boy, there's a misspelling in there I can't stand. So basically, before you execute this, it always checks this condition. If this condition is true, it does the following code. If this is less. So as long as I is less than 10, it's going to keep doing this. And then the last thing is the next step. This is executed at the end of the loop. Every time it's going to increment I or add 1 to I, so that I will eventually lead to this step. Now, it's important when you build a loop, just like in Python, is you always need to look at your code and make sure that it's going to end. In other words, you need to make sure that there's something in here that will become eventually false. And we know that's true here, because at the end of the loop, we're always incrementing I. So eventually it won't be less than 10 anymore. So let's look at another loop. This squares the number in the range of 5. In other words, it's going to take 0 times 0 plus 1 times 1, and then print it, and then print 1 times 1, then print 2 times 2, and go up to 5. right? So the code, again, we have a main. We say for I is equal to 0, so we start out with 0 and an I. We ask if I is less than 5, and if it is, we execute this code, and we're going to print 0 times 0 the first time. Then we're going to come back, and we're going to say, oh, we got to add 1 to, well, we added 1 to I, so now I is going to be 2, and we're going to, 1, we're going to print 1 times 1. Come back, it's going to be 2, print 2 times 2. Come back around, it's going to be 3 times 3. We increment it to 4. 4 times 4, we increment it to 5. It's not less than 5 anymore. 5 is not less than 5, and we terminate the loop.
Professor,
Yes.
for the plus plus iteration at the end, that always by 1?
No, it can be whatever you want. You can have I plus equal 2. You could have I minus 3. I is equal to I minus 3. You could do all sorts of stuff. We could actually show you this here. That's a very good question. Let's take this code, go over and create a new REPL. I don't know how I'm going to do that because this is, whoops, Reoak. All right, so now I need to, wait, that's not what I want to do. I want to see all languages, and we go in here, we better type 1 C++, there it is. Now we can create the REPL. You guys should try this too, and let's take and put this in here. And if we run it, notice we get 1, 0, 1, 4, 9, 16. That's the squares of numbers. Now I can make this bigger by making this number bigger, right? So let me fork this so I don't mess up the original. So if I make this to 10, by the way, notice you have to put, unlike the print statement, C++ doesn't go to a new line unless you explicitly ask it to. So we're just saying put a space at the end. So we can actually try this. Let's make it 100. And now we print off a bunch of squares, right? Now what I could do is I could say I is equal to I plus 3, and it should jump up by 3s. So we get less numbers, right? Now, of course, what if I do something like this? I is equal to I minus 1. Well, let's try it. Doesn't stop. Because we're counting down, and we're never going to be greater than 100 if we're always counting down. You see the problem? So we get an infinite loop. Right, so what if we do I is equal to I times 2? So you can actually do pretty fancy stuff here. Whoops. What happened there? Well, it started out at 0, so they didn't do much because 0 times 2 times 0. So if we start at 1, though, it should go up rapidly, right? 1, 4, 16, 64. It's going up rapidly because we're multiplying I times 2 every time. Kind of fun. Now, we've kind of glossed over the input and output. Let's talk about that for a second. Cout is an object. We've already talked about objects. Cout is an object, sorry, that provides for output to the screen. It is called the standard output. And in fact, it's C out because it's the C language and it's C's out. Now, this is a funny operator, but it actually makes sense when you start to get used to it. This less than less land is an operator that says, it's called the insertion operator, and it's used to insert data into your output to the screen. So thus, cout is an object, less than is a method on that object, if you use one way to think about it. So when we say cout less than output sentence, it prints the word output sentence on the screen. This prints what on the screen? The number 120, right? This is, since there's not quotes around it, this x is going to have to be a variable, and it's going to print the value of x on the screen. Now, we also have a cin, which is for our input. And that is an object that reads from the keyboard. And it will convert the input into the data type of the variable given, if possible. We use remember before it was the less than, we use the greater than operator, which is called the extraction operator, to pull something in, to extract it into your program. So if I have an int age, and I say cin into age, that's just like doing an input and putting the result into age. This is saying read something into age. Here I have a float and I'm reading something into float. Here I have an integer and I'm reading something into an integer. In fact, let me run these three pieces of code. Well, actually, no, let me just go to the next thing because that'll be better. Okay, so here's an IO example. We have all our usual gibberish at the beginning. We have our main line. And then we have an integer I, and then I say cout, please enter an integer value. Notice you don't have the ability to do an out as part of an input like you did in Python, right? Here we're asking for a value. Then I say cin goes into I, and then I'm going to say cout, the insertion operator. The value you entered is, and then I insert something else I. So you can actually insert multiple things. In fact, on this next line, we say cout, and it's double, and then we put I times 2, and then the last thing we print out is a period followed by a new line. So let's try that code, see what happens. So here it all is. Let's make sure it's all on the screen. Okay, so we run it. It says, please enter an integer value, 5. Right, now it's on line 10 waiting for input. Hit enter. The value you entered is 5. And its double is 10. So we'll try it again. 23. Its value entered is 23, and its double is 46. So this looks quite a bit different. It's going to take a little bit of getting used to, but it's actually still pretty simple, but it's just different from Python. Now, cin and strings. The string is a class in C++, which is actually true also in Python. A string is a class. It's not a simple object. It's a complex object. And it turns out char is only an individual character. String is a class. So when I say string my string, I can actually cin into strings, and I can cout strings. Now here's an example. Let's try this example here. So let's run it and then let's look at it. Let's have fun running it. It comes up, it says, what's your name? Jim Scon. Hello, Jim Scon. What's your favorite team? Kenyon Lords, of course. I like Kenyon Lords too. Wow, that is an incredible program. Now let's look at it. So here I have my usual include IO string, but I have something else. String is a class, so I have to include it. We put the greater than less than around it because it's a built-in class. It's not one we created. We have this that we always have without further explanation. And here we have int main, the beginning and end of our program. And I have a string called myString. And here I say, cout, what's your name? Now I'm going to show you another way to do input. If you want to input an entire line, you need to use a get line. So this says get line from the CN and put it into string, and then cout, hello, my string, and then a new line. What is your favorite team? Again, I'm using a get line. So it turns out that C++ by default, if you do it the extraction operator, in other words, if you just do the less than, or greater than CN, CN greater than, it only reads one thing at a time. And so you have to use a get line to get multiple things. In fact, let me show you what I mean here. Let's change this code. Let's not change that. Let's fork this. Oh wait, I didn't need to fork it because that wasn't the original. It doesn't matter. Okay, so let's for fun and grins, let's change this CN into the other CN, CN into my string, and then let's do it again here, CN into my string. Now, at first it might look like it's okay, because let's try this. It comes up and what's your name? Jim. Hello, Jim, what's your favorite team? Kenyon. Everything seems fine. But what if I type in, what's your name? Jim Scon. I hit enter. Hello, Jim Scon, what's your favorite team? I like Scon too. What happened? Well, it turns out that this type of CN only ever reads one element, and if there's a space, it waits for the next one. So it read the Jim in here and the Scon in here. Call that tokenization. There's some advantages to that. It makes some things easier than Python, but you have to understand it, which we will learn. We're going to be doing POJLs and everything on this, so fear not. So let's write a program that asks a user for their name and greets them with their name. Well, we kind of already did that, didn't we? I mean, if we want to ask somebody for their name, that's what we did here, right? And of course, the better way to do it is with the get line. If we want to get an entire name with spaces in it, or a Kenyon Lords instead of just Kenyon. Now let's try something else though. Let's modify the program such that only the users Alice and Bob are greeted with their names. So let's do this. Let's go back to here. Let's get rid of this other stuff. And let's do the other kind of CN. CN into, in fact, I don't like that. Let's change it to name. So string name. What's your name? We can get the name. So here's the string. What's your name? We can get to the name, and we can print hello. Not print. I'm stuck into the world of C out, right? Hello. Then I do the extraction insertion again, name. And then if I want to, let's say I want to put an exclamation point at the end, and then I want to go to a new line. Now, it turns out there's two ways to go to a new line. I can do a /n, or I can actually do an end-l, which I kind of like better. And then I have to do my semicolon. So this is going to print out the name. What's your name? Philander. Hello, Philander. Right? Not bad. Now, if I do this, though, if I do Philander Chase, two A's in Philander, but who cares? It's only going to say hello, Philander, because I only read in one word. Now, what do we need to do to only greet people whose names are Bob or Alice? Any ideas? In other words, we don't want to do this greeting unless they're Bob or Alice. What would we do? Anybody want to make a suggestion?
If.
All right, we want to use an if statement. Conditions are always in parentheses, right? So we could say if name is equal to Bob. Now in Python, well, we'll try this. Or name is equal to, what was the name we were worried about? Alice. Now after we do that, we got to do our squiggly things, our braces. I don't have to, but I'm going to tab this in to make it look nicer. So I'm going to say if the name is equal to Bob or the name is equal to Alice, print out our greeting statement. So let's try it. What's your name? Jim. Nothing. Hello, Bob. Right? Now, I actually wasn't sure whether this is going to work. Or and are actually relatively new additions to C++. Historically, C++ uses this for an or. But or also works, and also works. I'm going to probably usually use this because that's what I'm used to in C++. But or does work. That's a relatively new addition to the world of C++. All right. Write a program that asks for a number n and prints the sum of the numbers 1 through n. Huh. How might we do that? Well, let's see. New REPL. C++, create it. So we want to add for an n. So what do we want to do? Well, let's start out like our other programs always start. So let's just grab all, well, we don't need the string thing. So let's grab this one. We know we're always going to start our program with those 3 lines. So let's just go ahead and put them in there, right? And we know that at the end, we're always going to do a return 0. That just sort of gets us off on the right foot, right? Now, what do we want to do? We want to enter a number. So the first thing we need to do, because this is C++, is we need to define a number, integer n. Then we need to ask for a number. So let's, no, we have IOStream. Let's see out, give me a number, please. Semicolon at the end. So that should ask for a number. In fact, we can try that. Give me a number, please, and then it ends because we didn't do anything else. How do we input? Cn into n. That's it. Wait. Right? Cn into n. Now, we could test it so far and do a C out n and line. Let's just see if it's working so far. So we put in a number. So we put in the number 12. Sure enough, it prints 12. Yay, we did something right. So what we want to do is sum them all up. So how do we sum up a set of numbers? Well, we're going to need some sort of a loop, right? Let's start with a while loop, since we know those a little better, right? So what we could do is we could say integer sum is equal to 0, right? And then we need a counter. So we could say integer I is also equal to 0, right? Because we want to be able to count. And now what we could do is we could say while I is less than n. Oops, forgot the parentheses. Right, so while, as long as we're less than n, we could say sum is equal to sum plus n, right?
Don't you need your curly bracket?
Right. I'm so used to talking to you guys in, all right? Now that's not going to be enough. We got to put our semicolon in, but we also are going to need to increment our I, or we're going to get caught in a loop forever. So we now notice in C++, we can just say I++, and that's going to add 1. Now, when we're done, we should be able to print, nope, C out, quote, the sum from 0 to n is sum. The sum from 0 to n is sum. Let's see if this works. Give me a number 5. What should that be? 1, 3,
15.
15. What did we do wrong here?
We add n instead of I think.
That's right. We're adding it 5 times. So we got to change this to I here. And we'll try it again.
Oh, it's less than or equal to n. Not
Ah, right. So we want to go all the way up to n. So let's set this less than or equal to. We always have to test our programs. Wait. No, we supposed to be 5 is 15, right? So we do 10, we get 55. We do 120, we get 7260. Some big giant number. Ha! We got a negative answer as a result. Anybody have any idea what happened there?
is it out of the range of int?
Yeah. So Python, if you go out of the range, it will give you an error. C++ will not. Okay, so what happens is if you go beyond the limit of a number, and it turns out that integers in C++ only go up from -2 billion to +2 billion, which isn't that big of a number. And so we exceeded that number and we overflowed. And when it overflowed, funny things happen. Now, one way we could fix this, by the way, there's a type called long, which is also an int, but we can do a long. Actually, we don't really care about that number being a long, but we want our sum to be a long, because we want it to be able to get very big. So now let's try it. Let's take this, remember this same number, and let's try running it again. There, now it worked. Very big number, certainly bigger than 4 billion. But longs are pretty big. Isn't that interesting? All right, so let's go back to here. Modify the previous program such that only multiples of 3 or 5 are considered in the sum. In other words, we add a 3, we add a 5, we add a 6, we add a 9, we add a 10. And that's the numbers that get added if n is equal to 17. Huh. So we're going to have some sort of a if statement, right? In other words, what we can do is we want to have some sort of an fi, and we can do just like we did in Python. We can do I%, because it turns out the percent works. I%2 is equal to 0, or I%3 is equal to 0. Only in those cases. Whoops. Because we're saying only, multiples of 3 and 5. Oh, sorry. We're going to say if it's a multiple of 3 or 5, so we're asking if I mod 3, in other words, if the remainder of dividing by 3 is 0, or the remainder of dividing by 5 is 0, then we put in our brackets, and we'll put in a bracket after this, but before the plus, because we always want to increment I or we'll get stuck. So we run it and we do, 100, and we get 2418. And just to check it, let's see, make sure, let's see out I, and then when we're done with the while, we'll put in an end line at the beginning so that because that's going to keep us on the same line. So let's try this. So if we do 100, we can see we're adding 0, 3, 5, 6, 9, 10, 12, 15, 18. Isn't that cool? So all this would be easy to do in Python, and it's not too hard to do it in C++. Write a program that asks a user for a number m and gives them the possibility to choose between computing the sum and computing the product of 1 through n. Huh. We don't have a lot of time left. Let's look at the rest of these. Write a program that prints a multiplication table for numbers up to 12. And how about write a program that prints all prime numbers?
That's impossible.
That's exactly right, So let's try this one. Let's try to print a multiplication table. I think we're going to need a nested loop, right? So let's try that. Let's steal this program because it was already here. So what I could do is I'm going to need some variables, right? So I could do a variable R, int R, and I can actually do multiple variables in C for kind of row and column. And then I could say for, I'm going to try this, for R equals 0, as long as R is less than 12. Do we want to do it up to 12? Yeah, up to 12. So let's get it right. Is less than or equal to 12. And then we're going to say R plus plus. And then we're going to start something. Now I'm going to do within that, I'm going to do C's. I'm going to go C's up to 12. This may not look very good. We can think of a way to refine it afterwards. We could say print, no, C out. R times C equals, we'll keep it tight, R times C. And then we'll go to an end line to go to a new line. This is going to print a lot.
You're missing a bracket.
We missed our second bracket. Yes, thank you. So here's all of our possibilities. This isn't a very nice way to print it. What's a nicer way to print it? But this is the complete multiplication table, right? No, that's good enough because we're out of time. It has to be good enough. All right, so that's your hopefully reasonably gentle introduction to C++. On Thursday, we're going to do a POJL where you're going to actually sit down and do this. Okay? And so you should get in there and start playing around. You do have some C++ REPLs to do, but they're very simple. Okay, so play around with them a little bit, see if you can get it to work. And I will see you on Thursday, and thank you for coming to class.
Thank you.
Thank you, Professor.
See ya. Bye-bye.
Thanks.